Hey there, Mr. Weaver here, and this is Module 11, Lesson 6, Solving Quadratic Equations by Using the Quadratic Formula. After this lesson, you need to be able to solve quadratic equations by using the quadratic formula and use the discriminant to determine the number of solutions of a quadratic equation. Let's learn. Solving quadratic equations by using the quadratic formula. Completing the square, which we learned about in Lesson 5, for the quadratic equation, where it's ax squared plus bx plus c, produces a formula that allows you to find the solutions of any quadratic equation. This formula is called the quadratic formula, and it is x equals negative b plus or minus the square root of b squared minus 4ac, all of that over 2 times a. Now, there are many videos on how to derive or prove this formula out there. If you are curious, have a look, but we're not going to discuss that here. Why this formula is important is because that you can solve for any quadratic equation. Now, I know with the use of graphing technology like Desmos, we can go type them in and click on them, but if you have to actually graph things by hand, graphing is not necessarily always a viable option for solving quadratic equations. The same goes with factoring. If an equation cannot be factored, you can't use it. And we saw in Lesson 5 that when we're completing the square, if there's an a value that's not 1 and we have to divide that value out, numbers can get really messy, especially if all of the other numbers for b and c aren't divisible by whatever a was. Anyway, we have this quadratic formula that we can just plug in our values of a, b, and c and solve it out. It's pretty helpful. Example 1. Use the quadratic formula. Solve x squared minus 12x equals negative 11 by using the quadratic formula. So our first step here is going to be to rewrite the equation in standard form. So we need to add 11 to both sides. That way it's in standard form, ax squared minus bx plus c. So I would end up with x squared minus 12x plus 11, and now that equals 0. So this is the important format that we want, ax squared plus bx plus c, and then we'll set it equal to 0 if it's not already. Once it's in this format, our a value is the number in front of x squared, b is the number that's in front of x, and c is our number that's the end. Remember, the signs need to go with the numbers, so this here's a hidden 1. For the quadratic formula, we just plug in numbers and simplify it out. So it's negative b, or the opposite of b, so the opposite of negative 12, I just plug that value in for b, plus or minus the square root. b again, so negative 12 squared, minus 4, a was 1, c was 11, just plugging in the numbers. And then on the bottom I have 2 times a, so 2 times 1. Plugging in the numbers, make sure you have your signs correct. That's honestly one of the more difficult parts. Then we're going to simplify it out. So negative 12 becomes positive 12. Negative 12 squared is 144. Minus 4 times 1 times 11, so minus 44. And then 2 times 1 is just 2. We're going to continue simplifying. Now we're inside the square root is the next part we would need to simplify further. 144 minus 44 is 100. Now I can take the square root. So the square root of 100 is 10. The plus or minus symbol is already there, so we don't need to add it again. Just the square root of 100, put the positive version. So 12 plus or minus the square root of 10, all of that over 2. Then I would separate 12 plus 10 over 2, or 12 minus 10 over 2. So 12 plus 10 is 22. 22 divided by 2 is 11. 12 minus 10 is 2. 2 divided by 2 is 1. So the solutions after all of that are 1 and 11. So I plugged in numbers, simplified it out, get my answers. Check your understanding. Solve this equation by using the quadratic formula. Don't forget to put it into standard form first. Pause the video now and complete the check. Check your answer. You should have said 5 and 14. So first I would have to add 70 to both sides. So I'm just going to move this. It's now plus 70 equals 0. A is 1, B is negative 19, C is 70. So opposite of b, so I'm just going to do negative right away. So positive 19 plus or minus the square root, 19 squared, so negative 19 squared, but it's going to be positive anyway, minus 4 times a is 1 times c is 70, all over 2 times 1, so just over 2. Now, simplifying inside the square root, 19 times 19 is 361, 4 times 70 is 280, and then times the 1, taking the square root of that, subtracting 361 minus 280. I'm just going to keep simplifying the square root real quick. 361 minus 280 is 81. And then 81 square root is 9. So that square root part, I ended up with 9. So 19 plus or minus 9 all over 2. If I add I get 28. 28 divided by 2 is 14, which is right there. If I subtract 19 minus 9, I get 10. 10 over 2 is where we get our 5 from. Example 2. Use the quadratic formula when a is not equal to 1. So solve 2x squared plus 5x equals 12 using the quadratic formula. Unlike the other versions we've learned for solving quadratic equations, it's not super important when a is not equal to 1. We don't really have to do anything extra, we just have to remember that a is not equal to 1. So let's rewrite it into standard form, subtract 12 from both sides, we'd end up with 2x squared plus 5x minus 12 equals 0. Our a value is now 2, b value is 5, c value is negative 12. Plugging those things in, so I'm going to plug in my a value. You can see here, instead of it being 1, it is now 2, b, 5, and then c is negative 12. This time, we end up with negative 5 plus or minus our square root. We have 25 plus 96, which ends up being 121. And then our bottom, instead of it being divided by 2, it's 2 times 2, so dividing by 4. Negative 5 plus or minus the square root of 121 over 4. So the square root of 121 is 11. Separating them, negative 5 minus 11 or negative 5 plus 11, we end up with either negative 16 or 6. Negative 16 divided by 4 is negative 4. 6 divided by 4 is 3 over 2. Or if we divide that, 1.5. So our solutions are negative 4 and 1.5. You could leave this as an improper fraction if you wanted. So as you can see there, it didn't matter here if the a value was something other than 1. We just had to remember to plug in that a value instead. Example 3. Solve a quadratic equation with irrational roots. Our real context here is health. The normal blood pressure of an adult woman, P, in millimeters of mercury, given her age T in years, can be modeled by the equation P equals 0.01 T squared plus 0.5 T plus 107. If Seiko's blood pressure is 120, how old might she be? So here we can see we have some values that would make completing the square not possible and making factoring almost impossible to do. So here's where the quadratic formula might be the most useful method to use. So first we got to rewrite it into standard form. So we're setting the equation equal to 120 because we know that's what her blood pressure is. To put it in standard form, I'd have to subtract 120 from both sides. And I'd get minus 13 on the left with 0 on the right. So 0.01 t squared plus 0.5 t minus 13 equals 0. I now have my a value, my b value, and my c value. Let's plug them into our quadratic formula so we can see our values are plugged in. Again, we're simplifying out our square root first. So 0.25 plus 0.52 after I squared it and multiplied. Notice here we had a negative because of that minus in the original and a negative c value. So negative and negative made this plus this time. And on the bottom we have 2 times 0.01, so we're going to divide by 0.02. The square root of 0.77 is not a perfect square, so it's not going to come out nicely. This is where we're going to need our calculator. This becomes an irrational number, so we'll have to round it off. We're still going to separate our solutions, so negative 0.5 plus the square root, whatever that comes out to be, divided by 0.02, and negative 0.5 minus whatever that square root ends up dividing by 0.02. So we can just use a calculator. So when we add and then divide it out, we end up with 18.9, and subtracting, we end up with negative 68.9. Again, just using a calculator to come up with those answers, and rounding off to the nearest tenth. Now, because this has a context, we need to eliminate any unreasonable solutions. So here we were solving for t, which is a measure of age in years. So it's reasonable to assume that she's 18.9 years old, but because t is in years, negative 68.9 is not reasonable because we can't have a negative age. So again, be careful in context. If it's a t value or x value, make sure that you can have both positive and negative, otherwise eliminate the negative solutions. Check your understanding, read through the situation, and use the quadratic formula to solve when the ball would hit the ground. Pause the video now and complete the check. Check your answer. So t here is 6. So it took 6 seconds to hit the ground. For this one, I'm going to head over to Desmos and show you how you can use that to help you with the quadratic formula. In Desmos, if you type in the quadratic formula, so negative b, and then here you can't really put the plus or minus, so after we're done, we'll do plus, and then we'll change it to minus. So we'll start with plus, the square root, and we're going to keep typing the rest, so b squared minus 4ac, highlight it all over to a. So I typed in my quadratic formula here. I'm going to add a slider for all of them. And here, B came up first, so I'm just going to drag to rearrange so they're in order, A, B, and C. In our problem we just did, A was negative 16, B was 95, and C was 5.2. So notice when I type in A, B, and C, it gives me an answer up here. So negative 0.05. It's okay if your plus ended up being negative. Maybe that's the one we're supposed to cancel out. So let's switch this plus here to minus and see what happens. We end up with a different answer, 5.99. So our two solutions here were negative 0.05 and positive 5.99. So if you can remember what the quadratic formula is, you can always just go type it into Desmos, add some sliders, and use the calculator here to help you go through it a little quicker. As long as you remember to change it from plus or minus as you go to get both of your answers. And if you're having trouble remembering what it is, look up Quadratic Formula song on YouTube. There are a couple good catchy ones to help it get stuck in your head. Let's learn the discriminant. In the quadratic formula, which we can see here, the expression under the radical sign, so this part right here, b squared minus 4ac, is called the discriminant. And you can use that value to determine the number of solutions a quadratic equation will have. So if you want to know how many solutions something has before trying to solve it, then use b squared minus 4ac. Or maybe your question is just asking how many solutions does it have. There, you can just plug b, a, and c into the discriminant and use that value to help you out. So our key concept is using the discriminant, and it all depends on what the value comes out to be. So if the value is less than 0, meaning this part here is negative, then you end up with no solutions. That's because you are trying to take the square root of a negative number, and we can't do that to get a real answer, so there is no solution. Our graph would look like this. It has no x-intercepts. If that value inside is exactly equal to 0, so maybe you had 144 minus 144, you get 0. Taking the square root of 0 is just 0, meaning if you add 0 or subtract 0, nothing really changed. You get the same thing both times. That is when you have one solution. So your vertex is on your x-axis. The vertex and your only solution are the same. And then finally, if that b squared minus 4ac is greater than 0, so it's positive, then that's when you're going to get two answers like we saw in the previous examples. So it crosses the x-axis twice. So we end up being able to add whatever the number is and subtract whatever that number is, giving us two distinct answers. Example 4, use the discriminant. State the value of the discriminant of 4x squared minus 3x equals negative 1, then determine the number of real solutions of the equation. So our first step, we got to rewrite this in standard form as we've been doing for the quadratic formula. So add 1 to both sides, and now it is equal to 0. Our discriminant is just b squared minus 4ac. So we're going to plug in our values. We have a is 4, which we got right here. B is negative 3, which we got right here. And C is now positive 1, which we put over here. Now to calculate this out, I would end up with 9. Negative 3 times negative 3 is 9. Minus 4 times 4 times 1 is 16. 9 minus 16 is negative 7. So because the discriminant value is negative, it's less than 0, this means the equation has no real solution. We would be trying to take the square root of a negative number, and that can't happen. Check your understanding. Find the value of the discriminant of the equation shown, and then use that to determine the number of solutions. Pause the video now and complete the check. Check your answer. You should have said the discriminant is negative 63, meaning it has 0 or no solutions. A is 8. B is negative 15. C, when we bring it to the other side, would be positive 9. So b squared is 225 minus 4 times 8 times 9. We end up with minus 8 times 9 is 72 times 4 would be 288. We can see right away we're going to get a negative answer, negative 63, which means there's no solution.